Now we need to plot the waveform on the oscilloscope. We need to start by getting the ratio in dB, the ratio in a percentage of what 40 dB is the equivalent. So we have that the ratio is going to be given by 10 raised to the whatever dB here, dB by 20. In this case, we have that the ratio that we want is negative 40 dB over 20, and that is 0.01. Okay, now that we have the ratio, we need to attenuate the peak level voltage coming in from the transmitter. Okay, so we have that the peak voltage is in max is going to be attenuated by 0.01. Okay, that is going to be equal to AC max is 300 times 0.01. We move the decimal place 2 by 2, and that's equal to 3. We do the same for the modulation peak voltage. We multiply by 0.01, and it is 200, and that's equal to 2. Okay. So we have a modulation signal that has a carrier. Now the carrier has a frequency of 10 megahertz. The modulating signal has a frequency of 10 kilohertz. Okay, now this level here is Vmax. This level here is negative Vmax. Okay, this point here is Vmin, and over here is negative Vmin. Okay, now Vmax is going to be given by the peak voltage of the carrier plus the modulating peak voltage. We add those two, and that's equal to 3 plus 2. And notice that we are adding up the coupler level. Okay, so we have here 3 volts and 2 volts. Okay, so that's what we're adding down here, and that's going to be equal to 5 volts. Okay, and now for Vmin, it's going to be the difference between the carrier voltage and the peak voltage and the modulation signal peak voltage, and that's 3, that is 1 volt. Okay, so now we can plug in our values. We have here 5 volts, we have here negative 5 volts. Okay, V min is 1 volt, negative V min is minus 1 volt, and we have that the peak to peak V min voltage, peak to peak, is gonna be 2 volts. Okay, and the peak to peak V max voltage is going to be 10 volts. Okay, now from here we can calculate also the modulation index from the values that we have on this plot, and the modulation index can be calculated let's get up there, also by the difference between the between V max and V min over V max plus V min. Okay, and we have the V max is 10 volts, V min is 2 volts, and we have the then we have 8 volts over 12 volts, and that means that our modulating index is 0.667, which is the same, right? So we have 8 divided by 12, and that is 0.667. Okay.